wait, UV
Good that,
vis.
yes, good that you said this one to me. Guys, almost most of you, all of you, don't just rely. Yes, the manual we are giving you, sometimes we may make a mistake, guys. Most of you, the title of the experiment for EChem gave me, it was carbon voltammetry and blah blah finding fluoride. And then what happened to dopamine? I know sometimes you are just going and get it from manual, but if you see, if you feel something is missing, make sure you are completing it. You are in 451, guys. So make sure when you are giving this report to somebody that doesn't know anything about that report, can understand what was happening there. So please make sure that you are gonna add to whatever you are getting from the manual, if it's necessary. So right now, do we just do UV-Vis?
No, it's
It's
UV-Vis and
fluorescence
fluorescence.
spectra.
Absolutely, it's UV-Vis, and actually this one, even we used to call it fluorescence, not UV-Vis, because we had another experiment, particularly for UV-Vis, and we were building our spectrophotometer using the circuit, and that one we used to call the UV-Vis. This one, it was fluorescence, but of course, for running fluorescence, first part of this guy, first part of this experiment, it's about UV-Vis. Okay, let's go over manual. I'm sure you are gonna watch the video, but usually I suggest, like what Dylan did, you watch the video before you know my explanation. It's gonna help you a lot. So what we are gonna measure for this one, we are gonna work with 4 PAH, anthracene, chrysene, if I remember it, what was the other two?
Can I stop you there real quick, Margin?
Sure.
Real quick, because as I was doing an introduction and going through the experimental, I saw that it does say that we're measuring 4 polycyclic hydrocarbons.
Exactly.
But if we go to writing the report, it only talks about benzoathracene.
I'll correct that one. Thanks for noticing. Exactly. Last night I said, okay, let's go over this material in the beach board one more time. And good that I did, because I just noticed that we have mock data for UV-Vis just for anthracene. Okay. And I sent an email to Dr. Tia and I said, okay, are we running all PAH or just anthracene? And she said, no, I forgot to include, the rest of the data, but we are going to talk about all of them. So right now, guys, you have data for all 4 PAH. So you are going to do the benzoanthracene, chrysene, what is the other one? Why I can't remember.
It's part of the procedure.
Exactly. Yeah. So guys, 4 of them, for all of them, and you have data. Is that clear right now?
Correct.
That's correct. Yeah.
Shall we continue?
Yes.
Goody. So the major part, it's going to be fluorescence for this one. You know the story behind the fluorescence, so I'm going to leave that part for your class. Just briefly, we are going to make molecules excited. They are going to go to another electronic state, and then when they are coming back, they are going to give us the fluorescence peak. Of course, in the middle, we have rotational, vibrational. Because of that, if part of energy, it's going to be converted to those rotational, vibrational. Sometimes you will see that the lambda for fluorescence data, if you go very detailing for those parts, for fluorescence, the lambda that you are going to get the highest peak, sometimes it's a little bit shifting toward the higher one. It's, for example, for anthracene, absorption happening at 288 nanometer. So we know that we are going to get the highest and maximum for UV with at 288. So for lambda, when we are doing the fluorescence for anthracene, it might shift a little bit toward the higher because of, when it's shifting toward higher lambda, you all know means a little bit of less energy. So we are going to have those energies spent in vibrational and rotational sometimes. So don't be that surprised if you see it. But basically, a first part of this experiment, it's going to be UV-Vis. As you may see in the video, we are going to make a couple of solutions with a different range of concentration. And then you all, I'm sure, have seen the UV-Vis. We are going to fill the cell, okay, regular glass cell, with the sample and then one blank far from us. Then we are going to run the UV-Vis. Range was from 200 to 600. We are collecting the peaks, as you are going to have in mock data. I'll show you later. So when you are going to collect the peaks at some certain lambda, you are going to see the maximum. The most important part from UV-Vis, of course, you are going to use the mock data to make the graph in Excel. But again, from the data, you are going to recognize where is the maximum. Make a table, okay, and find out what is the maximum for each one. Then for each PAH, let's say we start with anthracene, then later we are going to do the same for the rest of three. So you are going to find, for example, for anthracene, all 4 or 5 concentration, 0.2, 0.51 ppm, all those, where you can see the highest absorption. Of course, it should be the same according to the lambda, just intensity of peak is changing with the concentration, right, guys? According to Beer-Lambert.
Correct.
That's
okay.
correct.
Then make a table of this one because you need to create a calibration curve exactly like Beer-Lambert one. And then from that curve, you are going to tell me what is the molar absorptivity. Most of you have done this one before. It's exactly like what you did in 111B and in 251. This part, nothing new for you. Right, guys?
Correct.
That's correct.
Exactly. Guys, let me tell you, this one was one of the most time-consuming experiment in the lab because of those solution making. Actually, you are lucky, guys, because barely and hardly a student could finish it in 4 days. Sometimes, most of the times, student didn't have time to do even the quencher part. Let me tell you, right now you are lucky. So you are going to repeat all those for anthracene, collecting data from the UV and making calibration curve. So far, 4 UV graphs, 4 calibration curve. Agree?
Yep.
That's right.
Okay. Then we are going to go, see guys, you have all explanation about the background. I'm not going to go over it. I'm sure you are going to read it and you have it in the class, the concept. I'm trying to, focus more in experimental aspect, that what I'm expecting you write down on the report, clearing those parts and how we are going to treat it in the lab. Sounds
Just a
good?
quick question.
Sure.
For the report part, would it be all right if we included like the little diagram of the spectrophotometer just to see how it works, or not to see how it works, but to kind of include that?
You need to include that one.
Okay.
Yes, please.
The little like infographic part, correct?
Exactly. You need to give me that curve that, that is coming from the UV. Because of that, I told you, you are going to give me 4 graphs of the UV data that it shows. Actually, guys, let's go overlay. You know what? For the UV part, give me one graph overlay, included all those concentration in one graph.
Okay, sounds good.
But I really prefer to have 4 graphs for calibration, because sometimes it's getting so, you know, busy and hectic, especially when you want to show 4 equations right there. If you think it's going to come out neat, you can do that. But remember, these are different range of PAH. So we can have, for each PAH, one overlay for UV data. Okay. For each PAH, give me a calibration one. If it's not that busy, if it's coming out neat, okay, you can have it in one. Okay, so that's the UV part. Do you have any question? Oh, let's not forget. Okay, let's go something right here. Right here, guys. For this experiment, you need to give me the limit of detection, LD and LOD. You have the formula here. If you don't, again, you can find it in the textbook of 251, or you can search it. But for finding limit of detection, you need to run blank for 20 times. As you can see, it says right here, right above the equation 6. Can we see it, guys?
Can you zoom in just a little bit on it? Or here, you know what? I'll just increase my screen size.
Yes, please. I don't know how to zoom.
All right, there. So it's is that SM equals S? Is that BL?
Exactly? This is the formula, but SM, it's gonna be you are gonna calculate it. SBL, it's gonna be signal for blank. BL is blank. So for finding signal for blank, you need to run blank, for this case 20 times. As you can see, it says above of it.
Is that why we were given the 20 scans of heptane?
Exactly. Thanks
All right,
for
that makes
going
more sense.
over the
Thank you.
data before. I'm going to show you the data again, guys. That's for this part. You have a data in mock data. It says it's running the blank for 20 times. That's for this purpose. Is that clear right now?
Yes.
Yeah, that's clear.
Wonderful. So you are going to use that set of data for finding limit of detection. Okay, dokies, let's say what we need from UV-Vis, in addition to what we are including in the lab report, we need those lambda maximum, okay? Again, for example, for chrysin, let me help you. If I remember it right, it was around 268, 267. For anthracene, it's 288. For the other one, 305. So each one has a different lambda max. So you are going to have 4 lambda max from UV part. Okay. You are going to use these numbers in fluorescence part, because this is where absorption, the highest absorption, is happening. So we used to enter this one in a machine for fluorescence, and then you are going to have again set of concentration for, as you can see right there, for fluorescence part. The same story as you may have seen in the movie, but this time we use a quartz cell, pretty expensive one, guys. One of my students broke it. We were in trouble. No, because we have to order it. We didn't have it. I have to go to any research lab. They had it to beg it for, okay, can we borrow it? Those. Okay, you don't have such a problem right now. Everything is online. So I'm just trying to tell you, okay, guys, it's not that bad right now. I know we are getting frustrated in Corona time. Okay, so you are gonna run the fluorescence. Fluorescence one, you are gonna get 3 peaks. guys, when I let me go. I'm gonna stop sharing one. Sorry, bear with me. Just giving you an idea. Can you see the whiteboard, everybody?
Yep.
Yeah, we can see it.
So for UV, you are gonna get like this one. Okay, this is the UV one. So lambda max right here, the absorption, you may have seen it before. When you are gonna run the fluorescence, you are gonna usually get 3 peaks. One big, one small, like that. This is happening. Of course, the biggest one, it's important for us. Excitation that you are gonna see it later, again, you are gonna have this one. So guys, if I wanna include all this in one graph, that is actually nice one. Usually I'm asking my student, okay, to do the same. Grab one set of data for any of this. Anthracene is nice, okay, for anthracene, just for one PAH, okay, and for one ppm. One set of data for anthracene, for one ppm. You may want to make a note of that writing. So include all those in one graph. I mean what? I mean the absorption. That's
So all of those I'm looking at
exactly
one right now. All that anthracene.
Anthracene data. So you are gonna show me, okay, this is the absorption. Then excitation, it's happening a little bit here, and then fluorescence, it's gonna be right here. It's good for you too. You are gonna see how this process is happening.
Okay, cool. And then you want it in that consolidated form, right?
Yep.
Okay, thank you.
It's coming like that. If you put it in Excel, because of those lambda, automatically it's coming out in that order. Because absorbance is happening first, then we are going to have excitation, then we are going to have fluorescence. You will see that, but how that one's happening.
Sounds good.
Wonderful. Thank you so much, guys. See, I'm trying to clear this part of the lab, then you can see what's going on there. Let's go back. Okay, okay. Can we see the screen, everybody?
Yes.
Yeah, we can see it.
Wonderful. Okay, so you have the experimental part, but usually you don't need it. So because it's gonna happen, you know, in the lab. So you are gonna prepare the sample, and then you are gonna run it in fluorescence machine. Of course, again, you are gonna collect data for those parts, make a graph again for each PAH, okay? You can go overlay for all concentrations for one particular PAH, and then make sure you are gonna make again the calibration curve according to whatever you have in the manual. Then you are gonna have, look at the part D right here, determination the PAH excitation spectrum. This one, it's just for one ppm. Can we see it, part D, guys, right here?
Yeah.
So you don't have different concentration, just for one. And then make a graph. You have the data right there. And then the last part, it's going to be quencher. What does quencher do? You had it in right there. Quencher, they are materials. Sometimes solvent is doing that. Sometimes, you know, other molecules. Here we are going to use bromoheptane. Usually bromine and iodine, they are large molecule. They are going to act as a good quencher. What is a quencher? Quencher is that you are going to make the excitation in fluorescence machine. So you are giving light to those sample. They are going to get excited. They are going up. And then when they are coming back in a regular fluorescence, we saw that we are going to get the fluorescence peak, okay, with a certain intensity right there. But quencher, they are materials, they are going to absorb energy when molecule is coming back, it's coming down, it's coming to the ground state. It's absorbing that energy. So you don't see fluorescence peak with the previous intensity, with the same intensity. And this decrease in intensity, it depends on how much quencher you are going to have there. Please take a look at this table. We will see right here. Can we see it, guys?
Yes.
You will see that we are going to take the certain volume of bromoanthracene, but we are playing with the volume of bromoheptane there. So we are increasing that one. Then when you are going to run all these data, you will see that by increasing the volume and amount of this bromoheptane that is quencher for us, you are going to get less and less intensity. Okay, so you are going to have decrease of that one. This one can be very obviously can be seen in one graph. So please give me an overlay of this part for the data of quencher that we can easily see how that intensity, it's going to get less and less. And then you are going to use that data in the quencher formula. Let me scroll up right here. Where do I have quencher part? Here, right here. So you are going to find the Stern-Walmer relationship. You are going to plug it right there and find the Stern-Walmer quenching constant using that data. So you have all the formula. Is that clear for quencher part? I know this is a very long one, guys. Don't leave it for last minute.
Well, Marjan,
yes.
so if I'm not mistaken, so the only time we're using every single pH is for the UV part and showing the relationship of the fluorescence intensity versus concentration, because for the rest of the experiment, it just focuses based off the Stern-Walmer, the fluorescence spectra. It only asks for benzoanthracene.
Absolutely right. So,
okay, so it's only UV-Vis that we're using each one.
Yeah, exactly. No,
awesome.
No. Hold on. Let me clear it. UV-Vis all for pH. Clear. Fluorescence part, fluorescence spectra, regular. Okay, for pH. Clear.
Yeah, that's clear.
For all UV-Vis for all concentration, all pH. Fluorescence, all concentration, all pH. Excitation for 1 ppm, all pH. Quencher, just anthracene. Was that clear?
Can you just go down over the on the bottom where it says lab report hints?
Yes.
On the bottom of the lab manual.
Absolutely.
Because what you're saying to me is kind of disregarding what it's saying in the
okay, let's
manual.
see. No. We may okay, good. I'm gonna check it because we have changed this one every semester. Okay. So because last semester we didn't have the data. Remember, guys, we collected all this in summer and let me see. So each part, let's see. Absorbance vs concentration of all pH, right? This is the UV-Vis.
Yes.
Fluorescence intensity, okay, vs concentration for all pH. Clear?
Correct.
Quencher for just benzoanthracene. Okay. And then where is the excitation?
It's the comparison between absorption,
compare the
excitation
and absorbance, right here. See,
it's only for one though.
No, for each pH.
It says for one chosen pH.
Where?
Number 5.
Number 5, comparison between the absorption. Yes, that one is just for one. That's what I did on the whiteboard. That one for just anthracene.
Okay.
Number 5, that's the graph. Okay, for absorption, fluorescence, and excitation. That one is what I did on the whiteboard for you. It was just 1 PAH. Remember?
Mm-hmm.
I wrote just 1 ppm anthracene.
Okay.
But look at the bottom of that when it says comment about detection limit of fluorescence and absorption.
Mm-hmm.
Compare the excitation and absorbance spectra for each PAH. So you need to give me 4 excitation as well. It's on top part.
Which is number 2.
Exactly.
Yeah.
Okay.
Okay. Makes sense.
Uh-huh. Okay.
Thank you, Marjan.
Shall we go out of the manual, take a look at the mock data?
It sounds good.
Okay, let's go.
Just a question as far as the Excel sheets for like the for the fluorescence part. Are we, when we put it into the report, are we able to consolidate
overlay for each PAH, if that was the question?
It wasn't as far as the graphs in terms of like including it in the, including these data tables in the report. It looks like some of them is just only 1 or 2 columns. Are we able to just kind of set those side by side and
yeah, you can do that.
Kind of
yes.
Indicate that they're different
in the Excel? Yes, you
okay.
can do that. Mm-hmm. So video, you are gonna watch it, and then you have some link that to YouTube. You are gonna see it better. So this is why I don't have the rest. I copied it today. Where did they go?
So it's at the very bottom of the table of content. Look at the very bottom. Keep going down. Module 4 added in a separate section.
This is the new one. Okay, guys. And remember, you always can get it from the section 4, your lecture part. Okay. But here we have it. See, anthracene was up there. I'm gonna move it later, okay, to the right place. I just did copy paste today. So you have UV for chrysene, you have UV for fluorescent and phenanthrene. Oh, okay. I didn't remember the name. Oh my God, I'm getting old. Okay, so shall we take a look at one of them? See, guys, you can just take those data and make a graph, and it's already giving you the overlay for all concentration. Take a look at right here. You can see, look at the 268. Let me share the screen again one more time with you. Can we see the screen, everybody?
Yeah, we see it.
Wonderful. Take a look at 268.
Yeah, that's lambda max.
Exactly. So easily you can find the lambda max and make, if you make a graph, you will see it. So this one was for chrysene. This is the UV data that you are going to make an overlay and make the calibration curve according to BR Lambert data. Then fluorescence, I have it right here. Let me go back right here because that's what. So you are going to have emission spectra. You are going to make a graph, excitation spectra, and you are going to have the quench. So treat the same. But guys, as you can see right here, you don't see that blank part. I figured it out right here. Let me, I think. I'm going to move all this to the right place. Don't worry, I'm just showing you. So you have 20 scans for heptane fluorescence. Okay. And then you are gonna, for limit of detection calculation, then you are gonna have the excitation one and you are gonna have the quencher. Any question?
I'm sure I'll have questions by Wednesday.
I think so. Guys, my suggestion, please, please, please start, this experiment right away. Do as much as you can. Then if you see you are gonna have any question or concern, you can share with me on Wednesday, next Monday, all those days. So watch the video and start working on your experiment. At least, graphing part, all those, if you are not starting writing about intro or abstract. Any question, everybody?
Seems straightforward, but I'm sure I'll have questions later once I start.
Absolutely, that's
working
pretty
on it.
normal. So AA experiment, last one was pretty straightforward and nice. So I saw that, but this one we may have questions. So I'm ready. Don't worry about it. I know what's happening. Okay, are we good, everybody?
Yeah, Margin. When can you send upload this video,
What video?
the recording of the Zoom meeting?
Oh, you need it? Okay, sure.
I say it'll help me go back and like, okay, she answered it right here and stuff like that, instead of having to just reach out for you and have you repeat yourself.
No worries. I'm gonna send it to all of you by email.
Awesome. Thank you so much, Margin.
You're welcome. Any question, guys? Don't worry. I'm gonna be here again on Monday.
I have a question, but I'm gonna stay behind after class. I'm gonna ask you a question.
Sure.
Thank you.
So everybody have a good day. If you don't have any public question.
Thank you.
Thank you.
You're welcome.